Series circuits. All circuits have three common attributes. These are a source of voltage, which you can see in all of these pictures, a load, here the load is the resistors, and a complete path. A series circuit is one that has only one path of current. Now what that means is if you start, let's look at the second one because they don't have the resistors connected here. If you start from the positive of the voltage source and you put a pencil down, you can trace the pencil all the way around without ever lifting it to get back to the end, and that is a series circuit. So if I wanted to make the top one into a series circuit, all I would need to do is connect here and just keep going with the path to there, and that one is a series circuit now. Series circuit rule for current. Because there is only one path, the current everywhere is the same. For example, the reading on the first ammeter or current meter is 2 milliamps. What do the other meters read? Well, obviously you can see they read 2 milliamps, but more importantly, this path that current takes around this loop right here is the same. So if I'm measuring 2 milliamps before resistor 1, I will also measure 2 milliamps after resistor 1. I will measure 2 milliamps before resistor 2 and 2 milliamps after resistor 2. Likewise the same with resistor 3. Series circuit rule for resistance. The total resistance of resistors in series is the sum of the individual resistors, which means you add. So for this bottom circuit, I would take 680 plus 1.5K is 1.5 times 1,000 or 1,500, and 2.2K is 2.2 times 1,000 or 2,200, and that gives me 4,380 or 4.38 kiloohms. Tabulating current, resistance, and voltage and power is a useful way to summarize parameters in a series circuit. Continuing with the previous example, complete the parameters listed in the table. So I1, I2, I3, and total should all be the same. More importantly, we found the total resistance was 4.38 kiloohms. So now to find current, I would take 12 volts and divide it by 4.38 kiloohms or 4,300, and that gives me 2.74 milliamps. I have 2.74 milliamps all the way around the circuit. Now, to calculate the voltage drops, V1, V2, V3, and my powers, I can use my current to do that because I have constant current through everything. I might as well use that as the identifier to help find the voltage drops and the powers. So V1 is current 1 times resistor 1. Obviously my current is just 2.74 milli, so it's 2.74 milli times 680, which gives me 1.86 volts. V2 is going to be my 2.74 times 1500, which is 4.11, and V3 is 2.2K or 2200 times 2.74 milliamps, which gives 6.03 volts. Now notice, the total of the voltages, if I add them, equals 12, which is my source voltage. To calculate power, I can use voltage times current. The important thing is, when you're using this formula, you have to make sure you use the correct quantities. If I'm looking for the power dissipated by resistor 1, I want to make sure I use the voltage across resistor 1 times the current through resistor 1. Now granted, the current through all resistors is the same because it's a series circuit. The voltages across each resistor are different. You do not have 12 volts across each resistor. You have a portion of the 12 volts across the resistor, as you can see like we just calculated. So V1, so this would be 1.86 times 2.74 to get P1. P2 is 4.11 times 2.74, and P3 is 6.03 times 2.74. Kirchhoff's voltage law is generally stated as the sum of all voltage drops around a single closed path in a circuit is equal to the total source voltage in that closed path. And as I pointed out in the previous example, if you add up all of those voltages, it will equal 12 volts, which is the source. Voltage divider rule. The voltage drop across any given resistor in a series circuit is equal to the ratio of that resistor to the total resistance multiplied by the source. For instance, assume resistor 1 is twice the size of resistor 2. What is the voltage across resistor 1? Well, you might say, well, how am I going to figure that out? I don't even know what resistor 1 and resistor 2 are. Well, if resistor 1 is some number, resistor 2 is twice that number. So my total resistance is going to be 3 resistors, because this one's twice the value. Let's just, as an example, if this was 1,000, then resistor 2 would be 2 times 1,000 or 2,000, so my total would be 1,000 plus 2,000, or 3 times 1,000, which comes out to my total. So V2 is going to be 2R1 times, or divided by 3R1 times 12 volts, so it's 2/3 of 12, or the R's cancel. 2 times 12 is 24, divided by 3 is 8 volts. A series circuit is a circuit with only one current path. Kirchhoff's voltage law says a circuit is a circuit law stating that the sum of all the voltage drops around a single closed path in a circuit is equal to the total source voltage in that closed path. Voltage divider is a circuit consisting of series resistors across which one or more output voltages are taken.